Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at literal equations. So by literal equations, it means they are equations with more than one variable. They have letters. They have a lot of different variables. And you're typically going to see literal equations when you're looking at different formulas. And so I want to talk about how we solve literal equations for a particular variable in the equation. So our first example is an equation or formula that's used in electricity or electronics, and it's Ohm's law. And it states that voltage is equal to current times resistance, and those are the letters that they happen to use for that. But the beauty about math and understanding equations is you don't even have to know what the formula is or represents, and you can still solve for any variable in that formula. So it just means that E is equal to I times R, and rather than learning three different formulas, what I is equal to and what R is equal to, if you have the ability to manipulate these formulas, then you can find what the other variables are equal to. So that's the idea in this video, is to be able to isolate any variable that's in an equation so that you can say what it's equal to. So in this first example, let's say we wanted to know what I is equal to. So we're going to solve for I. That's the instructions that we've been given. So if you're more comfortable, you can move, I times R equals E to the other side. It's up to you. But I want to get I by itself, which means I want to get rid of the R. And we know that this means multiplication, so we've already learned that in order to get rid of that, whether it's a letter or a number, we do the inverse operation. So the inverse of multiplying is dividing. So I'm going to divide this side by R so that it will allow me to get I by itself. Whatever I do this side of the equation, I do the same thing to the other side. So the R's will cancel. And I will have I is equal to E divided by R. That's a literal equation because we don't get a number. It's not full of numbers. There may be numbers in it, but it's full of other letters, and you want to be able to solve for any variable in that equation or formula. But it's the same process as what we were doing before. Our next example is circumference of a circle. Circumference is equal to pi, which is a special number in math. I think you've all learned what pi is. We use that symbol to represent it, times the diameter. So if I wanted to rearrange this and solve for the diameter, solve for D, very similar to the last one. I'm just going to keep it on this side. I'm not going to start moving it around, but I want to get rid of pi, so I need it's being multiplied to diameter. So to get rid of it, I divide, and I do the same thing to the other side of the equation. Same rule as I was doing before. So the pi will cancel. I'm left with D, and it's equal to C over pi. So I've just rearranged the formula to now get a new formula that tells me that the diameter of a circle will equal its circumference divided by pi. Let's take a look at some more. This equation represents a formula for converting Celsius temperature to Fahrenheit, and I might want to rearrange it so that I can convert the other way. So in order to do that, I want to solve for C. I want to find C if I know F. So that's what my goal is. So again, I want to isolate this term first. So I want to get rid of anything that's added or subtracted. In this case, 32. So I'm going to subtract 32 from this side. I'm going to subtract 32 from this side. So I'm going to have F minus 32 is equal to 1.8C. If you're more comfortable with flipping it around, so sometimes I will and sometimes I won't. You decide what you're comfortable with. I'm just showing you that it's not necessary, but you can. it gets our unknown term on the left-hand side, and I want C by itself. So because it's being multiplied to 1.8, I now need to divide to get rid of it. Whatever I do to one side, I do to the other side. The 1.8 will cancel, so C will equal F minus 32 divided by 1.8. And that would be my formula. I don't like it too much because I have a decimal in the denominator, but I'm not going to get picky about that in terms of simplifying. We just want to be able to use the formula, so I'll let that go this time. Let's take a look at some more. This next example is a formula that you would see in chemistry. It deals with pressure and volume and gas constants, temperature, and represents the number of moles, I believe. But it doesn't really matter if we know exactly what each of these variables represents. We can isolate for any variable in the equation by following the same procedures. So in this case, let's say I was asked to solve for t. This means n times r times t, and in order to isolate t, I want to get rid of n times r, which is being multiplied to t. So all I have to do is divide by n times r. If I do that to that side of the equation, I need to do it to this side. And the n cancels, the r cancels, and I'm simply left with a t. So t is equal to p times v over n times r. So I've just rearranged the formula or the literal equation to solve for a different variable. And that's all. It's just that you can't simplify. You don't have any numbers to combine or to multiply. So it looks more complicated, but it's the same process. Let's keep going. I wanted to look at this formula because it introduces subscripts for different variables. This is an actual formula. It's one used, it's a gas law, and it talks about the pressure and temperature of one gas. That ratio will equal the pressure divided by the temperature of a second gas. So these are not like exponents because they're subscripts, they're not superscripts, they're not up there like exponents. All they are is the name of the variable. So it's P1, it just means pressure 1. They have no numerical value, they just name the variable. P2 is pressure 2. So we just treat that like an X, that like a Y, that like a Z, that like another letter. So don't let those subscripts throw you. You are going to see those in formulas. So just accept that it's part of the name of the variable. All right, let's say I wanted to solve for T2. My first step I don't want to isolate this when it's in the denominator. You may run into problems. So let's do the strategy or the shortcut that we talked about in 2 videos ago, where we can cross multiply when we have an equation such as this, and then we'll worry about isolating T2. So I'm going to cross multiply. So I'm going to have P1 times T2 equals T1 times P2. Now that we have it in this form, it's going to be easier to solve for T2. This is the variable we want to solve for. It's being multiplied to P1. So we're just going to divide by P1 so that that P1 will cancel. What I do to that side, I have to do to this side as well. So the P1 cancels. I'm left with T2 is equal to T1 P2 divided by P1. And I could have solved for any variable. Whichever variable I was asked to solve for, I would have cross multiplied as my first step, just to get rid of the fractions, to get rid of the division created by the fractions. Let's take a look at one more example. All right, this formula is the ideal or the general gas law. Lots of variables going on. Again, we have the subscript, so pressure 1 times volume 1 divided by temperature 1. So those are the pressure, volume, and temperature of our first gas. That product and quotient will be equal to P2 times V2 divided by T2. So that refers to our second gas. And I could solve for any variable in here. Let's say I want to solve for, let's say, V2. My first step, regardless of which variable I'm solving for, would be to get rid of the fractions. I just want to get rid of the division created by those fractions, so I'm going to cross multiply. So I start here. P1 V1 T2 will be equal to T1 times P2 V2. Now that we have it in that form, it's going to make it easier to solve for the variable I want, which is V2. So I need to get that alone. I need to get rid of those factors. It's all being multiplied. So I'm going to divide by T1 P2. If I divide that side by T1 P2, I need to do it to the other side. And what will happen is the T1 will cancel, P2 factor will cancel, and I'll be left with V2 by itself. So V2 will equal P1 V1 T2 over T1 P2. So you're going to see lots of different formulas in different subject areas, such as physics, or if you do any electrical or electronics or any other application, you're going to see different formulas, and knowing how to solve equations, and in particular literal equations, gives you a lot of power to isolate for any variable and solve for any variable. And you often will be asked to rearrange your formulas in this way, not just in math, but in such a class such as physics. So that's the end of this video. I want you to try to find some of these, take a look at doing the rearranging, solving for a particular variable. And when you're comfortable with that, then we can move on to the next video, which is fractional equations. So this was a fractional equation as well as a literal equation, but we'll be looking at other types of fractional equations, and that will be coming up next. So practice this, and we'll see you on the next video. Take care.